The directions say to determine whether the series, and it's the summation from n equal 1 to infinity, of 1 times 3 times 5 times 7 all the way through until 2n minus 1 divided by 3 times 6 times 9 times 12 all the way through until 3n times 3 to the n over 2 to the n converges or diverges. This one is really, really, really subtle. Okay, so let's go to the next page, and I'm going to rewrite this summation. And so we're going to go from n equal 1 to infinity of. So we get 1 times 3 times 5 times 7 all the way through until 2n minus 1. So this one doesn't change, okay? Now in the bottom, I'm going to write this as 3 times 1 times 3 times 2 times 3 times 3 all the way through until 3 times n. Okay? It's subtle, all right? And I'm going to multiply this by 3 to the n over 2 to the n. Now, this is the summation from n equal 1 to infinity of. So again, I get 1 times 3 times 5 times 7 all the way through until 2n minus 1, okay? Now, in the denominator, I have, now watch carefully, I have 1 3, 2 3s, 3 3s, dot, 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 n 3s. So I'm going to write this as 3 to the n times. Now I'm going to get 1 times 2 times 3 all the way through until n, okay? And I multiply by 3 to the n over 2 to the n. Now, over here, the 3 to the n's cancel. And so, kind of like what we did in class, we're going to get the following. We're going to get 1 times 3 times 5 times 7 all the way through until 2n minus 1. That's the numerator. In the denominator, notice how we have n copies of 2. So every one of these factors is going to get doubled. And so, in other words, I'm going to write this as 2, and I'm doing this on purpose, times 4, times 6, all the way through until 2n minus 2 times 2n. And I'm doing this very deliberately. Okay, now, let's check this out. A sub n is 1 times 3 times 5 times 7 all the way through until 2n minus 1, okay? And we're going to divide by 2 times 4 times 6 all the way through until 2n minus 2 times 2n. Okay, now look at carefully here. I'm grouping this very deliberately because notice how 3 halves is bigger than 1, strictly bigger than 1. 5 fourths is bigger than 1. 7 sixths is bigger than 1. 2n minus 1 over 2n minus 2, right? That's bigger than 1. So I claim this is greater than 1 over 2n. This is greater than 1 over 2n for n greater than or equal to 1. Okay? Now, the summation from n equal 1 to infinity of 1 over n diverges. And this is P series. Okay? P equals 1, which is less than or equal to 1. So if I take a constant multiple of an already divergent series, that also diverges. So therefore, the summation from n equal 1 to infinity of 1 over 2n, we'll say also diverges. Okay? So again, a constant multiple of a divergent series diverges. Therefore, the summation from n equal 1 to infinity of a sub n must diverge by the comparison test. Okay? And so we can conclude that if we go back, that whole summation will diverge. So n equals 1 to infinity of 1 times 3 times 5 times ... times 2n minus 1 divided by. And then we get 3 times 6 times 9 times ... times 3n times 3 to the n over 2 to the n diverges. So really we're applying in a very subtle motion or a very subtle way, we are applying the comparison test. Okay, thank you.